Hello, algebra students. Mr. Lawrence here, and today we're going to be exploring absolute value inequalities. Yes, and I'm still in Florida. I just took a 2-mile walk at about 5 or 6 in the morning, and it is beautiful. Shorts and a tank top. Awesome. Wish you were here. Well, not here with me, but wish you were in nice weather. Anyway, okay, let's recall first that when we're finding the absolute value, we're finding the distance from some point, right, on a number line. Typically, the definition is the distance from 0 on a number line. And that usually leads us to find that there are two solutions, right? So we do x plus 4 equal to 7, or x plus 4 is equal to negative 7. And then we find the two numbers by solving the two different linear equations. So we get x is equal to 3, or negative minus 4 minus 4, and then we get x equals negative 11. Okay, so yeah, that's right. Okay, so when we come down here to do the absolute value inequalities, it's really pretty easy. It's very much the same thing, except one thing you need to know is that when you see this symbol or this symbol, I like to intentionally misread those. I like to call that a less than. Those are my ands. Remember the ands from when we did inequalities before? And then when I see these symbols, I like to call those great ors. Great ors. Okay, so less thans and great ors. That'll help me set it up properly, and that'll also help me with my number line. So problem number 2, I have the absolute value of 2x plus 1. Oops, sorry about that. Okay, the absolute value of 2x plus 1 is less than or equal to 0. So I'm going to break this up into two pieces. So I'm going to go 2x plus 1 less than or equal to 11, and 2x plus 1. And this is a little tricky. I need a negative 11 here, but I also need to change the direction of the inequality. Okay, now I don't like to do them this way, but a lot of you like to do them in two sentences. So I'm going to show you how to do it in two sentences, and then I'll go back and show you how I would do an and. But there's nothing wrong with doing it this way. Okay, so now I've got two linear inequalities, and notice the inequality changed direction. Okay, so I'm going to subtract 1 from both sides, and I'll get 2x is less than or equal to 10, and I'll divide by 2. And I'll get x is less than or equal to 5. Okay, over here I'll subtract 1 from both sides, and I'll get 2x is greater than or equal to negative 12, and divide by 2, and divide by 2, and I'll get x is greater than or equal to negative 6. Remember, it's an and, so on my number line, where are my lines? Might need to give myself a little more room here. Okay, so getting my number lines set up here, and get my arrowheads on there. So I need to show 5, I need to show negative 6, right? And I need some points. So there's a point, and it might just be easier to clone him after I fill him in. Okay, now I need the numbers that are less than or equal to 5, which would go this way, right? But I also need the numbers that are greater than or equal to negative 6, this way. So there is my shading. It's going to be all the numbers from negative 6 to 5. If I test it, pick a number in between there, say like 0. 2 times 0, get out of this. Okay, 2 times 0 plus 1. Well, that's going to equal 1, right? Is the absolute value 1 less than or equal to 11? Sure it is. But if I pick a number outside that range, say like 10, 10 would be over here, or 0, 10 would be over here, right? Watch what happens when I put 10 in. I get 2 times 10, which is 20, plus 1, I get 21. Is the absolute value of 21 less than or equal to 11? No, it's not. Okay, so it's really easy to test. All right, now I promised to show you how I do it because I do it slightly different. So it's the original problem was absolute value of 2x plus 1 less than or equal to 11. I don't like to do it as two different sentences. I like to do it as one. So I copy that down, but then I just work to the left like that. I put the same symbol to the left, and then I put a negative 11. And I like this better because it looks like it's sandwiched. Now, some of you are thinking you didn't change the inequality. I sure did, because first we wrote down 2x plus 1 is less than or equal to 11, right? And then the other way, I wrote down 2x plus 1 is greater than or equal to negative 11. Well, look, isn't the greater part of this inequality toward the 2x plus 1? And here my greater part is 2x plus 1. If you're going to do the little alligator thing, the alligator's eating the bigger number, right? 2x plus 1. Well then, it's eating the 2x plus 1. So I did flip it, even though it doesn't look like it flipped. Then of course, I like to solve it all as 1. Excuse me. So I'll get negative 12 is less than 2x less than or equal to 10. And then of course I divide by 2. So negative 6 is less than or equal to x, which is less than or equal to 5. And I got the same answer as you did doing it the other way. I don't care which way you do it. Whichever way is going to allow you to get the right answer, that is fine. Okay, number 2. I cannot write the ors as one sentence, so I'll have to do the ors as two sentences. But I start off exactly like I did. I write down what's inside the absolute value. I keep the symbol the same, and I keep that number on the end the same. Or 3x minus 2 is less than negative 4. So you see it flipped, right? The inequality flips and you change the sign. Okay, now I solve each part. So we get 3x is greater than 6. Divide by 3, divide by 3. X is greater than 2. Or adding 2 to both sides, I get 3x is less than negative 2. Divide by 3, divide by 3. X is going to be less than negative 2/3. So for my number line, okay, let's see here, get back to my pen, arrowhead, whoop, there we go, it's a little bit better. I'm going to need a 2 on there, going to need a negative 2/3. Okay, they're both going to be open points, right? And let me see. Okay, I need the numbers that are greater than 2. Well, they would be this way, right? And then I need the numbers that are less than negative 2/3. That would be that way. So remember what we learned with our hands, with the ands and ors, it applies to the absolute value inequalities. All right, let's look at a couple more examples, speed things up here a little bit. Okay, here I have a less than, and so I'm going to write it as one sentence. 5 minus 2x less than 17, and negative 17 is less than that. Okay. Oh, silly me. I've got to subtract 5 from all three places. So I get negative 22 is less than negative 2x, which is less than 12. And then I'm going to divide by negative 2, divide by negative 2, divide by negative 2. I'm dividing by a negative in inequality, so watch what's going to happen. I get 11 greater than x, which is greater than negative 6. And so if I go to my number line, I'll just draw one by hand here. I've got negative 6. I've got 11. They're both open points, and I know that I'm shading everything in between. If I go and test it, the numbers in here will allow me to get the right answer. For example, 0. 5 minus 2 times 0. Well, that's 5. Absolute value of 5, less than 17. It checks. Pick a number outside the range. Pick 12. 5 minus 2 times 12. Well, 5 minus 24 would be negative 17. Absolute value negative 17 would be 17. Is that less than 17? Nope, it's not. Okay, so 12 does not work. 24, be 19, excuse me. 19, sorry. Thought that sounded wrong. Yeah, okay. 24 minus 5 is 19. Okay, problem number 4 here. Well, we got 3 minus x greater than or equal to 6, or 3 minus x is less than or equal to negative 6. So I'm going to subtract 3, negative x greater than or equal to 3. I'll divide by negative 1, divide by negative 1. So x is less than or equal to negative 3. Or over here, subtract 3, and I'll get negative x is less than or equal to negative 9. Divide by negative 1, and then I will get x is greater than or equal to 9, and I can go to my number line. So I got negative 3, and it's a closed point, right? And I have positive 9, which is also a closed point. And I will shade greater than 9 and less than negative 3, and there you go. Okay, there's 2 more I want to show you, but I'm not going to tell you the answers. I want you to write these down in your notes, and I want you to think about what the answers need to be, and we're going to talk about those in class tomorrow. Okay, Mr. Lawrence signing off. Good night, everybody.